Okay, we're going to go on to topic 9.2 in additional exercises in our booklets. And they want us first to do some vocabulary. So the words are asymptote, decreasing, exponential, and increasing. Well, they look like things we can handle. A function in this form is referred to as an exponential function. A function f is what if values of f increase as x increases? Well, how about increasing? A function f is what if the values of our function decreases as x increases? Well, this function is decreasing. And the graph of a function has an x-axis. You recall it looks a little bit like so. What did we say the x-axis was, which was y equals 0? That was the asymptote. Okay, not too bad at all. Now, for this one, they're asking us to show, using this graph of a function, determine from this graph whether it's going to be this or this. Now here we see it increasing. So here it's going to be a is greater than 1. Remember, a cannot equal 1. And a can't be smaller than 0 either as we look at this. So let's look at the next one here. All right, this is one where we have our x's in the middle there. And we're calling our x the a. A is going to be less than 1 and greater than 0. Okay. Now for number 7, they're asking us to graph this. And in a way I kind of like it because it's giving me finally a way to show our little strategies that we've developed. I'm going to make a t-chart. And the values we're going to put are 0, 1, -1, 2, and -2. We could make more points, but this will give us enough to do our curve, and we don't have a lot of place in our graph here as well. So let's change colors. And we're going to do the 4th root of x. So if we put a 0 where the x is, 4 to the 0 power is 1. If we put a 1 there, 4 to the first is 4. Now if we take a -1 there, this becomes 4 to the -1, which is equal to 1 over 4, which is the reciprocal of this, 1/4. Now if we raise this 4 to the second power, that's going to be a 16. And 4 to the negative 2 is the reciprocal of this, which is 1/16. Now we're ready to start to graph. So again, 0, 1, right there. 1, 4, 1, 4. And notice we're almost off the graph already. So 2/16, 2/16, 16 is going to be way up there. So our curve then goes like, something like that. And then we're going to get a negative 1 1/4, which is right about there. Negative 2 1/16, which is right about there. And then this just gets closer and closer, which I can't really draw. So again, not too good a diagram, but not too bad. Now, let's do this one. Y, and again, we'll make a T-chart. And we often wonder, well, what points do we put here? Well, these are our standard. So 0, 1, negative 1, 2, negative 2. Now, notice what happens here. It's going to be 2 to the exponent, and then we subtract 3. Now, what is this in our graph, by the way? This is our y-intercept. But let's just do this, and I'm going to pause while we do it. So looking at this, it did take me a little while to set it up. This is our basic equation, which I have up over here. And then I'm using these points for my x value. So when x is 0, this becomes a 1. 1 minus 3 is a negative 2. Now if x is 1, 2 to the first power is 2. 2 minus 3 is a negative 1. And I also put the negative exponent there as well. And I did this over here. 2 to the negative 1 is actually 1/2, the reciprocal. And then we subtract 3. Well, 1/2 from a negative 3 is a negative 2 1/2, which I'm putting in there as a negative 2.5. Now, if x is a positive 2, 2 squared is 4. 4 minus 3 is a 1. And here, if I put in a negative 2 there, I get 1/4. 1/4 minus 3 is a negative 2 3/4. And that's what I'm showing here. That's a minus sign. And I'm putting that in as a negative 2.75. So when I graphed the 0, negative 2, that's my y-intercept. Then I do a 1, negative 1, so 1, negative 1 is right there. And then a negative 1, 2.5 is right there. A little bit lower maybe. And then I do my 2 and a 1. 2 and a 1 is right there. And that kind of gives me enough to do my curve. If I put in a negative 2, my 2 3/4 is right about there. And what do we note then as we look at this particular graph? Well, this graph has shifted down compared to our typical graph. Now this was a 4 up here. Now if it were a 3, it would have been in a little closer, and you can see the 4 is a little closer still, reflecting on things that are going to happen, and we covered in the textbook slides. All right, let's go on. Now for this one, let me develop what we could picture from it. All right, predicting a little bit of what we have here, this is going to be y equals 2x to the negative 3. If we had just as 2x, we got a curve that looked like something like that. And I had said that if there's a negative 3 there, it will shift or translate this graph. I'm going to change colors here. To 3 units over this way. So this graph is going to look like that 3 units over. Now let's see if we're right here. Again, plotting all these over there are kind of challenging. So 0, 1/8. That's going to be about there. Now 1 is 1/4. 1 is 1/4. Again, I didn't do that too well here. A negative 1 is 1/16. So a negative 1 is 1/16. That's going to be over there. A 2 is a 1/2. So 2 is 1/2. So notice this is about 1/2 over here. I probably didn't do that one too well either. Over there. And then a negative 2 is 1/32. We can't do that. 3 is a 1, so 3 is a 1. So I should have had that one a little bit better. So how many units, and we can see it right here, did we translate this graph to? Again, we said it was negative 3, that we would shift or translate it to the right 3 units. And that's basically what we've done. Okay. So number 10. Again, the answers to all of these are in the book. We want to give you a strategy for doing them. Now 10 gets a little challenging because of the fraction. Well, again, to help with the strategy of this, a little t-chart and a fraction. So again, we're using our points, our typical ones. So if x is a 0, anything to the 0 power is 1. Then if this is to the first power, it's just that. If this is to the negative 1 power, remember we said if we had 1/8 to the negative 1, we could just flip that, 8/1, and it became a positive exponent. So that's just 8. That is the reciprocal of this. And if we had x is 2, this squared is 1/64th, and the reciprocal of that would be, again, the 8 would go on top, you'd square it, and you get 64. And you can see we're off the graph already. So our line, if we were to sketch it, looks a little bit like so. So again, with the 1/8, we get very close. You recall that 1/4 went like so, and then actually 1/2 would be there, and then 1/4. Well, let me check that out here again. So 1/8, the smaller the number, the closer it got. So that would be what I said was correct. 1/4 would be out here. That's smaller than 1/2, which would be out there. Okay. Again, we're trying to show you some insight. And when you do the practice, they're going to give you the graphs already done. You have to sort of know what's going on so you can pick out which is the right one. They're not going to have you graph these. Okay, now let's take a look at number 11, and I'll set that up. Now, before I graph this, let's see if we can do a little brainstorming. We know that the graph of 2 looks something like that. And now we have a -1, which will indicate that that graph is going to translate 1 unit over this way. So if that's 1 unit, it's going to be like, still goes through there. Well, maybe it goes a little bit lower here, I guess. All right, and then a -4 will shift that whole thing down like that. Well, down to where closer, a little further down. So again, some brainstorming so you get some idea of how to graph this. Well, I spent a lot of time on this one, but again, I've worked out each of these carefully by substituting, and I get my values. I plot my values on the graph, and as we said, if it were y equals 2x all by itself, it would have been something like so here. And we said that this one was going to be shifted down, and it would be over to the right a little bit because of that. Instead of it being right on this line, it would be over a little bit more. All right, well again, try to recognize what they've done. When it's -1, it's going to be a translation this way, and if it's -4 over here for the y-intercept, that's not quite the y-intercept. The y-intercept was actually a -3.5, but you see it does shift it down. That's basically what I want you to pick out of here, and it is a challenge. All right, let's go on. Now, some of these, they want you to do them with your calculator. I'm not going to go through all of that. If you have a calculator, you plug that in and it works out very well. And the graph is in our booklet here. But let's do this one because what they've done here is they reversed the letters. And I want to illustrate this one. And I want to show you the strategy of this as well. Oh. So we set up the t-chart in a sense the same way, but now the values that we start with will be our y values. So 0, 1, -1, 2, -2, and let's see if this gives us enough. So if y is 0 and it's 2 raised to the y power, this is just going to be 1. This is just going to be 2. Now we get our reciprocals, 1/2. This is going to be 4. This is going to be 1/4. And this is going to be 8. And it would be negative 3 would be 1/8. So again, this is the easiest to graph, but what does it look like? Well, let's do it. So 1, 0, 1, 0, 2, 1, 2. Now, negative 1, 1/2. Negative 1, 1/2. Well, let's do that again here. I'm plotting it backwards. 1/2, negative 1. So 1/2, negative 1 is right there. Okay, 4, 2. 1, 2, 3, 4, 2. Negative 2, or 1/4. 1/4, negative 2, right about there. And then 8, 3. Well, 5, 6, 7, 8, 3 is right there. So we see we get this type of thing. Oop. Missed that point. Okay, so that is the graph of this. Now for number 14, we would do basically the same thing, but 14 would be something like this. I'm going to just sketch this from what they have in our textbook here, off like so. Again, putting that into your calculator, you get a nice little graph out of it here. Let's go on. Now for this, they want us to graph both on the same set of axes. So I'm going to just sketch this using techniques we've developed. So 4 we know is going to be it's going to go through 1. And if 2 was out this way, 4 is a little tighter. Now, what will be the reciprocal of this? Well, it would be this. And if we did I'm trying to show techniques here. This is our axis of symmetry. And if we plotted this line symmetric to this, let's see if I can sketch it here in red. So it'll be sort of like that, and like that a little bit. And again, what you're going to have to do is, they're not going to ask you to graph these in MATLAB. They just want you to pick out the correct graph. And these get to be challenging, and they are in our book, so we're not going to do that either. So I spent enough time. Okay, on this one too, they're saying here's our estimated population of Ethiopia in these 2 years, and they want you to graph this function. So you're going to put, let's say, a time here. Oh, this would be after 3,000. Okay, so that would be like the first year, let's see, how many years would this be after that? This would be a 5. 3 from 8 is 5. And then this would be 7. So we'd put a 5 there, a 7 there, calculate this. And again, the graph is in the booklet. And this would be something similar. And that's all you're going to be doing. And again, your main work is practice and your quiz me's, and then in preparation for our paper test. And my examples aren't going to be the hardest ones, more on the easy side. Lots of stuff to do here. And shortly we'll be doing logarithmic functions and see how they relate to what we've just been doing.